let's it is visible, so let's move ahead. So what we are going to discuss in this lecture is low allocation in particular cell, or in cell or cells, right? So if there is no allocation, so what we are going to do, if there is no allocation, it means that no allocation means no unit transportation. No allocation means no unit transportation cost has been given due to non-availability of route. That route unavailability can be for various reasons. So what we are going to do, put infinite transportation cost for that cell and proceed. Solve numerical in usual manner. Okay, so this is the case. So no allocation to be done to a particular cell means that no unit transportation cost has been given because of the non-availability of the route. It may be due to various reasons like flood and strike, and due to some natural calamities that may happen, earthquake. So now what we are going to do, so if the transportation cost is not given to us, we are going to assign a very high transportation cost called as infinity, and then we are going to proceed. So if we don't want allocation in that particular cell, that means that no, what normally we do is that we allocate, we do allocation in that cell where the unit transportation cost is less. But now that we know that I don't have to do any allocation in a cell. So so what I'll be doing is that I'll be assuming a very high transportation cost, say infinity, and because of that, there will be absolutely no chance of me giving some allocation in that cell, right? So naturally it will be getting avoided. So what we have been given, there is a numerical. We have 5 factories with us, and we have 4 factories and 5 warehouses with us, and they have given the transportation matrix to us, transportation cost matrix, right? So these are the factories A, B, C, D. These are the warehouses, and there are 4 factories with us, for which the unit transportation cost has been given to us. Right, so this is the unit transportation. This is the transportation matrix. You can see this particular cell and this particular cell. They have not given us the unit transportation cost. So that means that I can't transport goods from factory 1 to warehouse B, and I can't transport the goods from factory 4 to warehouse D, right? So the supplies and the demands are also given to us. So I'll be just writing the supply and the demand that are assigned to us. So that are 200, 175, 150, 325. Next it is 110, 90, 120, 230, and 160. So these are the unit transportation cost. These are the supply and the demand constraints that are given to us, right? So we have to what we'll have to do is that we have to put the infinite transportation cost in cell 1B and 4D, and rest is nothing but the state, right? So same procedure we are going to follow. So let's check. Let's start solving. So if I check what is the total demand and the total supply. Let's check this. So my total supply will be 200 plus 175 plus 150 plus 325. So if you do the addition, it comes to be 850 units. And if I go with the demand, so 110 plus 90 plus 120 plus 230 plus 160 is equal to 710 units. So here if you see, your supply is greater than the demand. So if supply is greater than the demand, so here what will happen is that this is unbalanced transportation problem, right? And if it is to be converted into a balanced transportation problem, what we'll have to do is we'll have to add extra factory or extra destination. We'll have to add a extra destination, extra warehouse taking care of the excess supply. Therefore, add extra fictitious warehouse F having demand कितना होना चाहिए डिमांड 850 minus 710 having demand of 140 units, right? So this is 850 minus 710, right? So this is how this it has been addressed. So it is a unbalanced transportation problem in which no allocation is to be done in the particular cell or cell. So such combinations may be there while you solve the numerical. So now let's move ahead and frame out let's try finding the initial basic feasible solution. So what I'll be doing is initial basic feasible solution is to be found out. 2, 3, 4, 5 and 6. 2, 3 and 4. 1, 2, 3, 4, A, B, C, D, E, and our one more warehouse, that is F. So what has been given is that I am writing. So 13, here I am writing infinity. Here it is 31, 8, 20, and this is 0. Next it is 14, 9, 17, 6, 10, and 0. It is 25, 11, 12, 17, 15, and 0. 10, 21, 13, here it will be infinity, 17 and 0. So the demands are there with us. The demands are 110, 90, 120, 230, 160, and here it will be 140. Supply is already known to us. It is 200, 175, 150, and 325. So now we'll be finding the initial basic feasible solution by Vogel's approximation method, that is VAM method. And for the VAM method, we'll have to firstly go and calculate the penalties. So let's start from column A. So column A, we have 13 and 10. So the penalty is 3 here. Nextly, we have 11 and 9. So the penalty is 2. Nextly, we have 13 and 12. So the penalty is 1. We have 6 and 8. So the penalty is 2. We have 10 and 15. So the penalty is 5. And lastly, we have the penalty as 0. Similarly, if we go and calculate with the rows, so firstly we'll have the penalty, that is 0 and 8. So the penalty comes out to be 8, right? Nextly, it is 0 and 6. So the penalty comes out to be 6. Nextly, it is 0 and 11. So the penalty comes out to be 11. And nextly, it is 0 and 10. Penalty comes out to be 10. Maximum penalty is for row number 3, and the allocation that we can be done is in this particular cell, and the maximum allocation that I can do is how much? It is 140. So I'll be doing the allocation here. 140 will become 0 here, so I'll have to cancel this, and this is balance 10 that will be here. So all this column will get exhausted because the 140 units allocation is there. Recalculating the penalties for column A, it will be the same. That is 10 minus 3 is, 13 minus 10 is 3. Next it is 11 minus 9, it is 2. For column C, it is 13 minus 12, that is 1. For column D, it is 8 minus 6, that is 2. For column E, it is 15 minus 10, that is 5. For rows, now the rows penalties are going to change. Let's recalculate it again. So here we have 8 and 13. So 13 minus 8 is 5, right? Let's move ahead. We have 9 and 10, 6 and 9 here. So the penalty comes out to be 3. Then we have 11 and 12 here. So 12 minus 11, the penalty comes out to be 1. And for lastly, we have 10 and 13 here. So the penalty comes out to be 3. So now if you see the penalty, the maximum penalty is that we have come across is 5, and it is for row 1 and column E. So for row 1, if we consider, so there is a tie, right? So we have to solve this tie. So for row 1, the maximum allocation can be done in this particular cell, and the maximum allocation that I can do is 200, right? If I consider column E, the maximum allocation can be done in this particular cell, and the maximum allocation that I can do is 160. So 200 is greater than 60, so I'll be doing the allocation here, that is 200, and I will be saturating this particular row completely. So now here 30 is pending, and completely this particular penalty will get crossed out, right? Now recalculating the penalties for all rows and column again. For column A, if you see, it is 10 and 14. So we have 14 minus 10, that is 4. Nextly, for next column, that is column B, we have 9 and 11. So 11 minus 9 is 2. For column C, it is 13 and 12. So 13 minus 12 is 1. For column D, we have 17 and 6. So 17 minus 6 will be equal to how much? It will be equal to 11. Nextly, we have 10 and 5. So the penalty will be 5 here. Right. Let's move ahead with now rows penalty. For column for row number 2, it will be 9 minus 6, that is 3. It is already there. Nextly, we have penalty as 12 minus 11. That is 1, that is already there. And lastly, we have the penalty, that is 13 minus 10, that is 3. So now we have maximum penalty of 11, and the 11 penalties to be handled. So the maximum allocation that I can do in this is to be done in this particular cell, and the maximum allocation I can do is 30, right? So 30, I will be making it 0. So this entire column will get exhausted, and you have 145 units pending here, right? Now recalculating the penalties again. So for column A, it is 14 minus 10, that is 4. For column B, it is 11 minus 9, that is 2. For column number C, it is 13 minus 12, that is 1. For column number E, it is 15 minus 10, that is 5. For column number, F is already exhausted. So now next row, for column number, for row number 2, the penalty comes out to be, row 2 is not yet exhausted, right? So for column row number 2, the penalty now can be recalculated as 10 minus 9, that is equal to how much? It is equal to 1, right? For next row, we can recalculate the penalty. So it is 12 minus 11 still, so that is 1 only. Nextly, for our last row, we can recalculate the penalty here. So it is 13 and 10. So 13 minus 10 is 3. So the maximum penalty is for column number, column E, and the allocation that I can do is in this particular cell, 10. So the maximum allocation that is possible here is how much? It is 145. So I'll be doing the allocation of 145 here. So entirely this row will get exhausted, and 160 minus 145 is equal to 15. So that I'll be writing here, right? Recalculating the penalties for my column and row again. So for column A, it will be now 25 minus 10, that is equal to 15. For column number B, it will be 21 minus 11, so that comes out to be your 10, right? For column C, it will be 13 minus 12, that is 1. Column D is already exhausted. Column E, the penalty will be 17 minus 15. The penalty is 2. Column F is already exhausted. For row number 3, now the recalculation of the penalty, that is 12 minus 11. The penalty remains same, that is 1. And for row number 4, it is 13 minus 10. The penalty remains 3. So the maximum penalty is obtained, that is 15 for column number A, and the allocation that we can do is in this particular cell. Okay, so the maximum allocation that is possible is 110. So I'll be doing the allocation of 110 here, and I'll be saturating this particular column completely, right? So 325 minus 110 is equal to how much? It is equal to 215. So 215 is pending here. Let's recalculate the penalties again. So for column B, it is 21 minus 11, the penalty is 10. And for column C, it is 13 minus 12, the penalty is 1. For row number 3, the penalty is 12 minus 11, that is 1. And for row number 4, it is now 13 minus, the penalty is going to change or remain constant. The penalty is going to change. It is 17 minus 13, that is equal to 4, right? So now the maximum penalty is obtained for maximum penalty is 10, and it is obtained for column number B, and the allocation can be done in this particular cell. So the maximum allocation that I can do is how much? It is only 10 here. So the 10 allocation is done, and 80 is still pending, right? So if I do 10 allocation, this entire row will get exhausted, right? So now we have only 2 cells that are remaining pending. So this is this cell and this is the cell, right? So we have to do allocation here, and we have to complete the allocation. So here I can do the maximum allocation of 80, and here I can do the maximum allocation of 120. So this entire cell will get exhausted. Now you can see all the allocations are okay. Here it is 15 pending here, so this will be 15 0. So here all allocations are done. So the number of allocations, will next count out what are the number of allocations and check if it is a degenerate or non-degenerate solution. So here we have 1 2 3 4 5 6 7 8 and 9 allocations, right? And m plus n minus 1 will be equal to 6 plus 4 is 10, and 10 minus 1 is equal to 9. So this is a non-degenerate solution, hence we can proceed further for optimal check, right? So optimality check, we all know, is to be done by UV method. So I'm redrawing this particular solution, and we are going to check for hence optimality. Hence proceed for check of optimality, right? So let's complete as many as iterations. I don't know how many iterations will be required. We have 1 2 3 4 5 and 6 number of factories. Right, 1 2 3 4 A B C D E F, right? So I'm just copying the solution. So it is 13 infinity 31 8 20 0. It is 0 0 0 49 17 49 17 6 10. Next it is 25 11 12 17 15. Lastly we have 10 21 13 infinity, and 17. So we have all these allocations with us. Right, so we have to find out what is the value of u1, u2, u3, and u4. We have to find out the value of v1, v2, v3, v4, v5, and v6. Right, so let's start. 1 2 3 4. As we missed one of the allocations somewhere, so allocations are to be properly written. It is 140. We have 9 allocations, right? So for all allocated cells, let's move, that is u1 plus v4 is equal to 8. We have u2 plus v4 is equal to 6. u2 plus v5 is equal to 10. Nextly, we have u3 plus v2 is equal to 11. u3 plus v6 is equal to 0. We have u4 plus v1 is equal to 10. u4 plus v2 is equal to 21. u4 plus v3 is equal to 13. Lastly, u4 plus v5 is equal to 17. Right? So what we are going to do is put v1 is equal to 0. Therefore, u4 is equal to 10. If u4 is equal to 10, v2 is equal to 11. If u4 is equal to 10, v3 is equal to 3. If u4 is equal to 10, v5 is equal to 7. Using the same data upwards, if v5 is equal to 7, u2 comes out to be 3. If u2 is 3, v4 is also 3, and v4 is also 3. So if v4 is 3, u1 comes out to be 5, right? Similarly, u3 plus v2. So v2 is 11, so therefore u3 comes out to be 0. And if u3 is 0, v6 also comes out to be 0. So let's put out all this value. u1 is equal to 5, u2 is equal to 3, u3 is equal to 0, u4 is equal to 10, v1 is equal to 0, v2 is equal to 11, v3 is equal to 3, v4 is equal to 3, v5 is equal to 7, and v6 is equal to 0. Right? So for all unallocated cells, right, so I'll be writing all unallocated cells. So it is p1a, p1b, p1c, p1d, and p1. Also p1d is already it is allocated, so it is p1e and p1f. Next it is p2a, p2b, p2c, and p2e. Sorry, p2f. Next we have it as p3a, p3c, p3d, and p3e. We have p4d and p4f to be found out. So p1a, so let's find out. 5 plus 0 is 5, and 13 minus 5 is 8. p1b, 5 plus 11 plus 5 is 16. Now infinity, it is an infinite value, so addition and deletion from an infinite value will be infinite only. So p1b you will be writing as that infinity only, so that there will be no allocation in that particular cell, right? So this is one more important thing. Similarly, if you have to write, p4d is also infinite, right? So p1c, if I go for p1c, it is 5 plus 3 8, 31 minus 8 will be equal to 23. p1f, if I have to find out, so it is 5 plus 7 plus 5 is 12, 20 minus 12 is 20 minus 12 is 8. Lastly, P1F is 5 plus 0 is 0, and 0 here now it is 5 plus 0 0 0 minus 0 minus 5 is minus 5, right? So let's move ahead and calculate a few more this thing. P2B now, no sorry, P2A. So P2 is 3 plus 0 is 3, 14 minus 3 is equal to 11, right? Nextly, P2B is how much? It is 11 plus 3 is 14, and 9 minus 14 is equal to minus 5. P2C is 3 plus 3 is 6, is 17 minus 6 is 11. P2F is 3 plus 0 is 3, and 0 minus 3 is minus 3, right? So P3A is 0 plus 0 is 0, 25 minus 0 is 25. P3C is 0 plus 3 is 3, and 12 minus 3 is 9. P3D is 0 plus 3 is 3, 17 minus 3 is 14. P3E is 0 plus 7, that is 7, and 15 minus 7, sorry, what we are going to find out? P3E. So P3E, 7 plus 0 is 0, and 15 minus 7 is how much? 15 minus 7. No, you yourself can do this, or as a practice as well. So it comes out to be 8. So P4F, lastly we have it as, sorry, P4F is 10 plus 0 is 0, and 0 minus 10 is minus 10. So here we have a negative value, here we have a negative value, and here we have a negative value. So as they have negative value, this is not optimal. Iterate further. So where we are going to put now, when we go for iteration, where we are going to put it, we are going to put in P4F, because it has the minus 10 value, right? So P4F is this particular cell, right? So P4F, we are going to do allocation here. So we have to frame out a loop, and then only we can do. So if we have to frame out the loop, how it will be looking like? So the loop will be formed like this, right? So it is plus, it is minus, plus and minus. So on where there are minus sign, it is 140 and 80. Minimum across that is 80. So no, we are going to add and subtract 80 at each of these locations. Therefore, new solutions that we are going to get. I'll be just writing the new solution, and then you can carry forward this problem at your end. Therefore, new solution obtained is, okay. So A, B, C, D, E, and F. You have 1, 2, 3, 4, right? So just writing all these values: 13, infinity, 31, 8, 20, 0, right? Then we have 14, 9, 17, 6, 10, and 0. We have 25, 11, 12, 17, 15, and 0. And we have 10, 21, 13, infinity, 17, and 0, right? So the new that we are getting is, we'll be getting, I'm writing the previous allocations that I have. So the new 80 plus 10 will be here, it will be equal to 90. Here it is 140 minus 80. So it will be equal to, how much? It will be equal to, I guess, 60, right? So we have here as allocation as 80, which is a new allocation, and 80 minus 80 will be 0. So that I'm going to ignore, right? So this is the new allocation. You can know see how many allocations are there. 1 2 3 4 5 6 7 8 and 9 allocations are there. So again you can start here. Number of allocations is equal to 9, and m plus n minus 1 is equal to 9. Hence proceed, right? So hence proceed matlab kya? Again you have to give the optimality check by u and v method. So no, I request you to carry forward this numerical and carry forward till the optimal solution is reached. So I